Hey there, Physics 20s. So I'm going to go over here, questions 6 and 7 here, just because, why not? I was just asked about them, and I realized I didn't make a video for this section. So here we go. I'm going to use this diagram here to figure out a ball that's shot from a cannon at a degree of 40 degrees here, with a muzzle velocity of 85 meters per second. How much time does it take the ball to reach its maximum height, and then what is that maximum height? And really, that's it. All right, so not even asking for the range, which could be a legit question. Maybe you can answer that as like question 8 or something. What's the range of this ball? But let me just draw out here a little vector diagram first, because this is going to be one of those kind of T-chart questions. So we're going to want to figure out what are the components of this velocity here. All right. So right now we have a velocity here is 85 meters per second. And we have components, an X and a Y component to this. So our Y component being the vertical and our X being the horizontal, and we're at 40 degrees. So what I'm going to want to do is I'm going to want to calculate our X and Y pieces. So making sure our calculator is in the right mode, it looks like it is. To calculate our Y piece, we're going to go sine, because it's across from the 40. So 85 sine 40 degrees, and that's going to be 55-ish. I'm going to write down actual units here, 54.6369 meters per second. My X piece is going to be cos. So I got my hypotenuse of 85, cos 40, and that's going to be pretty easy to do. So we got about 65.113 or so. Okay, so I got all these numbers in my calculator now. Now I just got to figure out where they go, right? So since we're trying to find maximum height here, I'm going to want to create a T-chart. All right, so right over here, I'm going to create a little T-chart. There we go. And we're going to have two parts to this T-chart. I got the horizontal section, my X section, right? And I got my vertical section. This is my Y section here, okay? And I'm going to put my velocity in the correct spot. I'm going to fill out the pieces that I know. So in the horizontal direction, because there is no acceleration, because acceleration here is equal to 0, the force is up and down, it's not side to side, so nothing's going to be affecting the speed this way, so there's no acceleration, no change of velocity. So I only have one average speed, which is going to be 65.11377 meters per second. Okay. And remember, the only formula I'm allowed to use on this side, because there is no acceleration, is v is equal to d over t. Now, on the other side, I could start filling out some other pieces of information, like, oh, I have acceleration this side, right? Let's say up is positive, right? So my acceleration here is negative 9.81 meters per second squared, right? And because I have acceleration, then I have these other pieces, vi, vf, a, t. So I have all these other things I need, dt, sorry, that I need to fill out. All right? So we're looking for, like in the second question, we're looking for the d, and the first question here, we're looking for the t. So we're looking for those two things, and I have a vi here. So remember, this 85 does not belong in this chart, right? Only the components of the 85 can go in here. So that's 65 in the x, and the 54.6369 meters per second in the y spot. Now, because I'm trying to find the maximum height here, all right, because I'm trying to find the maximum height, my VF is going to be 0, all right? It's going to be 0 meters per second. Because I'm reaching that maximum height, it's got to go up, 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 it's got to stop and then come back down. Horizontally, it's still moving at 65 at that point. But vertically, it slows down until it stops, and then it starts coming back down. Okay, so now once we have three things, and I have three things here, I just need to find a formula that involves these three things to find time. And it doesn't have d in it, and the one down here doesn't have t in it. All right, so those are the differences between these two questions. So this one here, I'm going to use the delta v over delta t formula. And remember, delta stands for change in, right? So I got final minus initial. There's my delta t. We're trying to solve for t here, so I'm just going to rearrange that for t by timesing the t up to the numerator and dividing the a down to the other side. Okay. So VF is 0, so 0 minus 0 minus that 54 number. I'm going to divide it by negative 9.81, and I'm going to get 5 point, let me just write down the answer here. So 0 minus 54.6369 meters per second. I'm going to divide it by negative 9.81 meters per second squared, and I get a delta t of 5.5695 seconds. So that's going to round off to B, 5.57. Okay, the next one, I want to find D, but I don't trust that time, right? So I'm going to find another formula that doesn't have time in it. So VF squared is equal to VI squared plus 2AD. My VF is being 0 again, so that's going to cross off. So I have 0 is equal to VI squared plus 2AD. And then I'm going to start rearranging this. So I got minus VI squared is equal to 2AD. And then I'm going to divide by, I'm trying to find D. So I'm going to divide by 2. 2 and 2 and A. Negative VF squared divided by 2A. So that's going to be, so let's go back to my calculator here, find that number. So what is this one? The 54 number. Okay. I'm going to take that number, I'm going to square it, divided by 2 times 9.81, or negative 9.81. Make sure when you divide it by 2 numbers, you actually divide by 2 numbers, and you don't just divide by 1 number. All right. And we get 152. So there we go. That's going to be B. Hope that helps, and I'll see you in the next video. Bye.